seen how to find reactions for a simply supported beam with a point load. Let's look at something very similar. What happens if we swap those reaction supports to a fixed support, making our simply supported beam into a cantilever beam? Let's find the reactions for that next. So, looking at this beam here, I've got a free end at A, I've got a fixed support at B, and I've got the same 10 kilonewtons at a distance 1 meter from A. Looking at B, I can see that this is a fixed support. That means that there are 2 unknown force reactions and 1 unknown moment reaction. 3 unknowns in total, however we also have 3 equations of equilibrium in 2D, therefore the number of unknowns equals the number of knowns, and we can solve this. We will start off by drawing a free body diagram. So stripping all the things that we do not need and drawing in forces for those unknown reactions. So I've got these following distances. Got 1 meter and 3 meters. I've got this force of 10 kilonewtons at 1 meter distance from A, and at B I've got reaction support. So I've got Bx, I've got By, and I've got Mb. So 2 unknown forces and 1 unknown moment. Now the great thing about a fixed support is that in each of these directions of unknowns, Bx, By, and Mb, they do not depend on each other, meaning that I can write the equations in any order that I want. I've assumed all of these to be in the positive directions of my sign convention, meaning that if anything comes out as positive once I've solved it, I've assumed the direction correctly. If anything comes out negatively, I've just assumed the wrong direction and the reaction is in the other direction. Let's start with the sum of forces in x equals 0, with this being my positive direction. So I've got Bx and nothing else, so that equals 0. Moving on to sum of forces in the y direction now, with this being my positive y, I've got By in the positive direction minus 10, because that's the negative direction, equals 0. So By works out as 10 kilonewtons. And the fact that it came out as positive means that that direction that I assumed, By going upwards, is correct. Now the last thing that I need to do is sum of moments. I am going to sum the moments around B. And the reason I'm going to sum them around B is that the 2 forces that pass through B will not contribute to moment. I can also do moments around A, and we'll do that to check. If I do moments around A, I do need to utilize By. And if I utilize By, if I made a mistake in By previously, that'll not give me the correct answer. So starting off with moments around B equals 0. So around B, By and Bx, as we said, pass through. They don't have a distance, they don't contribute. I have, though, a positive moment already, Mb, and I also have a moment from that 10 kilonewtons. Let's first discuss the direction, okay? So the moment for the 10 kilonewtons, this is its line of action, right? And it needs to return to point B. So it'll need to turn like this, right, in this direction. And that gives me a positive moment, right? It's anti-clockwise. So plus 10, the force, and the distance. The distance is always the perpendicular distance. So in this case, I've got a force in y. The distance is going to be in x. This is going to be the distance. And that distance is 3. And there is nothing else contributing to moment, so that has to equal 0. And mb, therefore, works out as minus 30 kilonewtons times meter. Now that minus means that I assumed that the moment is positive or going anti-clockwise. In reality, it is going in the other direction. So now that we've found everything, let us draw that on our free body diagram. So first thing first, Bx turned out to be 0, so we can get rid of that. By turned out to be plus 10, so direction is correct, and I've got 10 kilonewtons going this way. And our moment, Mb, turned out to be negative, so in reality it's in this direction, and this is 30 kilonewton meters. Once I've drawn it in the correct direction, I can get rid of that 0. So this is my cantilever beam with the reaction forces all drawn. I am going to do one last thing. I am going to do a check. And the way I'm going to check is I'm just going to check by doing moments around any point that I want. We're going to do moments around A. Now we know that the moments around A have to equal 0. So let's see what we get. I've got the 10, this time contributing a negative moment. So minus 10 times 1, okay? So that is this 10 here. Then I've got another moment from 10, only this time it's the 10 at point B, that reaction force, which gives me a positive moment. So plus 10 times 4, because that is the distance from that line of action of 10 to A. And then I've also got that 30 kilonewton meters, which is already a moment, so I don't need to multiply it by anything. It gives me negative 30. So I've got minus 10 plus 40 minus 30, and that equals 0, just as it's supposed to. So tick there, and I can assume that I've calculated everything correctly. And that's it. We've found the reaction forces at the fixed end of a cantilever beam with one point load. Now that we've seen how to solve a simply supported beam and a cantilever beam, we can mix up and add some different forces. So let's do that next time we meet. Bye for now.